Hi everyone, welcome to our live. This will be again a review of our module. This will be included in your exam. So I understand you were able to read chapter 2 or module 2 already of advanced and college algebra. So for today, we're just going to um, review what was written in your module, and just in case you guys will have some questions or there are things that you would like to clarify, and maybe we're not able to understand some of the concepts in the module, then this is the right time for you to do. Okay, so I'd like to welcome our six participants. We have six students right now. So yeah, this hopefully the rest will join us. I know it's a busy time for you during this time of the day, but just like what I've been telling you, this is the only time where I get a good signal of my Wi-Fi. Kasi nasa baryo tayo, so I know that you guys can relate to that. All right, so yeah, lots of you are saying good afternoon to me. So good afternoon, and I think we have to start. So I'm going to share to you our module. Okay, I know you have a copy, but I'm just going to show this on your screens for us to be able to see the module. So what we are going to discuss for today would be on operations involving algebraic expressions. If you remember last time, we talked about algebraic expressions, polynomials, and also we evaluated um, polynomials or algebraic expressions. So these were discussed last time. And today we're just going to continue, and this time on operations on algebraic expressions. So yeah, so when we deal with the operations in on algebraic expressions, we need to consider how do we group algebraic expressions. Okay, um, it's very important that we know how to perform the different operations involving algebraic expressions when there are groupings. Okay, so we have some rules here in removing grouping symbols. Okay, remove grouping symbols starting from the innermost grouping symbol, then combine like terms. Okay, we made mention about what do we mean by like and unlike terms last time. So we combine the like terms and continue working on the outermost grouping symbol until the simplest expression is obtained. So in other words, when there are grouping symbols involved, and a lot of them are, there are a lot of grouping symbols involved, we have to start at the middle, okay? And then we proceed to the next until we remove all the grouping symbols and until we obtain the simplest expressions, okay? The grouping symbols would be a parentheses, a bracket, or braces. So when removing grouping symbols, okay, this usually is the order. We remove parentheses, brackets, and then braces. Okay. So to remove parentheses preceded by a positive sign, simply drop the parentheses without changing the sign of the terms inside. Okay, that's very basic. So for example, here we have 8y plus negative 5y minus 20. So we just drop the positive sign here and retain all the signs between each term in the expressions. Or usually, so we have here 8y plus times a negative, so that will be negative. So you will have 8y minus 5y positive and negative also, so you will have negative 20. So here we group similar terms. 8y and 5y are similar terms, so we can perform the operation. 8y minus 5y will give you 3y minus 20. Okay, so that will be the simplified version of this expression, which has a parenthesis as a grouping symbol. To remove parentheses preceded by a negative sign, change the sign of the terms inside the grouping symbol to their opposites. So for example, here you have 2y minus, okay, the quantity 2y plus 24. So it says here, you just change, okay, the sign of 2y, which is positive 2y, it will become negative 2y. Positive 24, it will become negative 24. Or, of course, just like what I said, you can distribute the negative here because 3y minus, when you say minus the quantity 2y plus 24, is like multiplying a negative 1 and distributing it to the two terms inside the parentheses. Okay, I'm sure you know that. So negative times positive 2y will give you negative 2y. Negative times positive 24, negative 1 times positive 24 will give you negative 24. Since these are two similar terms, 2y minus 3y minus 2y, that will leave you with a y or 1y minus 24. So that's how you do it. Okay, so let's take this example. Um, we have here 5x minus the quantity 2x minus the quantity 3x minus the quantity 5x minus 4y minus 10y. Okay, that's a lot of grouping symbols in there. So based from our rules, we start from the middle, initially with the parenthesis. So this is the one at the middle. So you have a negative here times 5x minus 4y. Okay, so we simplify this. So this will become negative 5x. So this is what will happen if you multiply a negative with positive 5x. The negative times negative 4y, so you will have plus 4y. So we were able to remove now the parentheses. And then the next grouping symbol would be this. Okay, so you will have what is left here is 3x minus 5x plus 4y minus 10y because this is part of this grouping symbol. So now we have this whole expression and we have a negative here. So we distribute this again. Negative times 3x will give you, parang may nawawalang expression dito. No. We have to simplify first. I'm sorry. So we have here similar terms. 3x minus 5y will give you minus 2x. Minus 5x, I'm sorry. Then we have positive 4y minus 10y will give you negative 6y. So you were able to simplify that. Then we can proceed with multiplying the negative sign here. So negative times negative 2x will give you positive 2x. Negative times negative 6y will give you plus 6y. Okay, so we were able to eliminate another grouping symbol. And then we have this grouping symbol left, and there is a subtraction operation here. So we do the same. But before we do that, we have to simplify similar terms first. So we have 2x and 2x here. And if you're going to add that, you will have 4x plus 6y. Then we multiply again the terms in this grouping symbol with a negative or negative 1. Negative times 4x will be negative 4x. Negative times positive 6y will give you negative 6y. So what's left would be 5x minus 4x minus 6y. And these two are similar. So we perform the operation 5x minus 4x will leave you x minus 6y. So we were able to simplify this expression into x minus 6y, right? So Again, just remember the rule. You start from the middle, and then you proceed to the outer grouping symbols until you eliminate them. And while doing so, you have to simplify, okay? Group similar terms and simplify until you will get the simplest expression. All right, so I'm going to leave example number 2. Okay, now we proceed to addition and subtraction of algebraic expression. We actually did that in the previous example, but of course it involves variables of the first degree. So here we can see a lot of exponents happening here. So when we add or subtract algebraic expression, of course, again, we combine similar terms and then perform the operation and until such time that we will come up with the simplest expression. All right, for those of you guys who just joined us, welcome to our lecture. Yeah, there are only 7 of you here right now. Okay, so we proceed here in our example. This time we are performing subtraction and addition. So in our example here, in adding 2a squared plus a minus 5 and a squared minus 2a plus 3, we combine similar terms. So again, based from our definition of similar terms in our previous discussion, okay, they should have exactly the same variables. Okay, so here a squared and a squareds, definitely these are similar terms. So we group them together. So 2a squared plus this positive a squared here. Okay, we put a grouping symbol here plus what else? A and negative 2a. Okay, these are similar terms or like terms. So we have a minus 2a. Then we have here a constant number, which is minus 5 and positive 3. Then we group them also, minus 5 plus 3. Okay, so we perform the operation. 2a squared plus a squared will give you 3a squared. A minus 2a will give you negative a, and this is positive. Positive times negative will give you negative a. Then we have here plus negative 5 plus 3 will give you negative 2. Okay, this will be negative because positive times negative is negative. So you will have negative 2. So this is simplified now as 3a squared minus a minus 2. Now we also have here uh, the quantity 5x squared minus 7x plus 2 plus the quantity 6x minus x squared plus 6x plus the quantity 3x plus 2x squared minus 1. Wait for a while. Okay, so I'm back. All right, so I think we have 3 additional viewers. We are now 10. Okay, so yeah, let's continue. Let's have a second example. So here, we're just going to group similar terms. Okay, if you can see, we have x to the second degree. So let's see if there are other terms which is similar to 5x squared. So we can spot it immediately. We have 5x squared, we have minus x squared, and we have positive 2x squared. So we can combine them. Okay, so we'll have 5x squared here minus x squared and plus 2x squared. Then let's see what else can we combine. We have negative 7x, positive 6x, and positive 3x. Okay, so we can combine them together. So we have here now plus minus 7x plus 6x plus 3x. And then the constants, we have 2, 6, and negative 1. So you have plus the quantity 2 plus 6 minus 1. So we can perform now the operation. 5x squared minus x squared is 4x squared plus 2x squared will give you 6x squared. So here we have plus here. We have negative 7x plus 6x is negative x plus 3x will give you positive 2x. So we have here positive 2x. Then we have 2 plus 6 will give you 8 minus 1. That's positive 7. So this expression here is reduced into 6x squared plus 2x plus 7. Okay, can you give me the answer for letter C? Will you perform the operation? And let's see if you can get the answer. This should be easy. Okay, please type your answers in the chat box for letter C. Okay, let me just enlarge letter C. I think that's the largest it can get. So we have letter C here, 3x squared, the quantity 3x squared minus 1 plus 2x minus the quantity x squared minus 5x plus 3. Okay. May I know what is your answer? I think you will not have any problem with exponents on your phones because it's easy to type exponents on our phones, right? You just press it, okay? Hold the number and it will become an exponent. We have Raylene Franco answered 4x squared minus 3x plus 2. Let's wait for the others if they have another answer. Thanks, Raylene, for your answer. You guys can get your pens and paper if you're at home, so you can try to solve. You take note of the operation between the two grouping symbols. It's minus. Okay, may I hear from the rest? Christine answered 2x squared plus 7x minus 4. Who else would like to give the answer? Thanks, Christine. How should I call you? Is it Christine or Jade or Kristen Jade or KJ? How about the rest, guys? Come on. Just give me your answer. I just want to know if you have similar answers or what. Yeah, so we can figure out just in case your answers are wrong. So Divina, I think, or DG, uh, is polishing her answer. All right. So who else? No more? Okay, let's check if... What's the answer? Let's try to solve this one. Okay. So if we're going to rewrite this, so we can have 3x. I will just use caret, guys, for an exponent. So if you're going to group this one, you have 3x squared. Then we have a negative and a positive x squared. This will be minus x squared. And we proceed to the next. So you will have plus 2x. This one here. But we have a negative sign here, or a minus. Minus times, or negative times negative 5x will give you plus 5x. And then next, plus, you will have negative 1, this one, minus 3. Negative times positive 3 will be minus 3. So if we simplify this, you will have 3x squared minus x squared will give you 2x squared. 2x plus 2x plus 5x will give you plus 7x. Then plus negative 1, negative 1 minus 3 will give you negative 4. So that's minus 4. So the answer should be 2x squared plus 7x minus 4. I think it's the same answer with Christine. Rayaline, I think what happened to you is you failed to recognize the minus sign between the two grouped expressions. So since there is a minus sign here, you have to multiply this with all the terms on this side, because minus the quantity x squared minus 5x plus 3 is like saying negative 1 times x squared minus 5x plus 3. So you have to distribute negative 1 by multiplying each on the terms inside the parenthesis. So this will become minus 2x squared plus 5x, then minus 3. Okay, so that's probably where the confusion happened. That's why you came up with a different answer. Okay, so yeah, you try to um, look into that so you won't commit any mistake next time when performing this kinds of operations. So the answer here is 2x squared plus 7x plus minus 4. Okay, do you guys have questions at this point? Hey, good evening, Divina. I think Divina just joined us. Okay, so I think that's clear enough, I guess. So we shall now proceed to our next topic, which is on exponents. Okay, let's move this back to where it used to be. Okay, so exponents. The positive integer exponent x to the n means that there are n factors of x, or x times x times x, and so on, or x is multiplied n times, where n is an element of the natural numbers n. Okay, so for example, if we have 3, the quantity 3x squared to the fourth, it means that we are multiplying 3x 4 times to itself. So 3x times 3x times 3x times 3x. Okay, while 3 times x to the fourth means that 3 times x times x times x times x. So you see, guys, these two are different. The quantity 3x to the fourth and 3x to the fourth are two different exponents. Okay, here we are raising the whole 3x 4 times to the fourth power. Here it's only x, and 3 is not being multiplied to itself. Okay, to itself. Now, for us to better understand exponents, especially when performing multiplication, okay, or if there are like uh, when an exponent is raised by another exponent and stuff like that, okay, you know what to do. So let's take a look at the laws of exponents. So here, first law would be x to the m times x to the n is equal to x m raised to m plus n. Or in other words, the product of two exponents having the same base is equal to the base itself raised to the sum of their exponents. Take note that for the first law, for you to be able to get the sum of the exponents, the bases should be the same. Okay, so here m cubed times m to the fifth. If you notice, we have the same base, which is m. So what you're going to do here by applying the first law is you're just going to add the exponents. So this will be m raised to 3 plus 5. So therefore, m cubed times m to the fifth will give you m raised to 8. Right? Okay, so we have another example here. Yeah, I think this is another example. So we have 3x squared times the quantity 7x raised to the 7th. So what we're going to do here is to check if they have the same base. Yeah, they have. It's both 3x and x here. So since here it's only x that is being raised and not 3 is not included, same is true here. So we can separate the numbers, the constant, because the operation involved ay pare-pareho naman siya na multiplication. So you can take 3 and 7, you multiply them 3 times 7 kasi multiplication naman lahat yung operation dito. So 3 times 7, and then you group these two, x squared times x to the 7th, okay, which is like what is illustrated in the first law. You add their exponents. So 7 times 3 or 3 times 7 will give you 21. X 2 plus 7. So 21x to the 9th. Of course, guys, this is still applying the first law of exponent. Now we also have here the quantity 2a plus b squared times the quantity 2a plus b cubed. Now, the whole of this is being raised to 3, and same is true with here, which is being raised to the number 2. So you check out. So this will serve as the base. So we have 2a plus b, that's the base, and we also have 2a plus b. So we say that these are, they have the same base, so we can apply the first law. We just add their exponents. So this will become the quantity 2a plus b raised to 2 plus 3. These are their exponents, 2 plus 3. So this will be 2a plus 5 raised to the fifth power. Okay? So yeah, that's for our first law. And now the second law, we have the quantity xy raised to m is the same as x raised to m, y raised to m. Okay? So you distribute the exponent if the operation is multiplication. Okay? It's a different story if, for example, we have 2a plus b. Do not be confused of raising the quantity 2a squared plus b squared. That's not the case because the operation here is addition. You can only do that if the operation is multiplication. Say this will become 2 times A times B, the quantity squared, then that's the time that you can square 2, you can square A, and you can square B. But in this case, the operation is addition, and you cannot do that. You cannot apply the second law. So example, we have 5, the quantity 5xy cubed. So following law number 2, you have 5 cubed x cubed y cubed. So 5 cubed is 125, then you have x cubed y cubed. Okay, that's the second law. Then we also have the third law. So the third law says that x to the m to the n. Okay, so this exponent is being raised to the n power. So what you're going to do here is you just multiply this time their exponents. When x to the m, when an exponent is raised to an exponent, then you multiply their exponents. So for example, x squared raised to the fifth will give you x raised to the second power times 5. So this will give us x to the 10th power. Okay, now let's have another example here. We have 3, the quantity 3x cubed times y squared raised to the second power. Okay, so note that the operation in between these 3 is multiplication. So we apply law number 2 and then this. Okay. No, I mean, this is a product of this one. Okay, multiplication. Sorry, I got myself confused there for a while. All right, so what we're going to do now is we apply this. We have 3 squared. Yeah, we applied. I was right all along. Okay, so we have 3 squared. Then we have x cubed squared would be x cubed times 2. Then you have y squared. Squared is y squared times 2. So you will have 3 squared would be 9. And then you will have x. 3 times 2 will give you 6, x to the 6. And then you will have y to the 4th. That's the third law of exponents. Guys, you can just type anytime if you would like to ask questions or if I am confusing you, you just let me know, right? So here in the fourth law, this would involve division. X divided by y, or x over y, the quantity x over y raised to m. So again, you just raise both the numerator and denominator with the power m. Of course, that is assuming that y is not equal to 0. Okay, so we have here an example, 4x, the quantity 4x over 5y raised to 4. So you're going to raise everything that is found in the numerator and in the denominator with 4. So in this case, we have 4 times x. So you will have 4 raised to 4 and x raised to 4 times x raised to 4 over our denominator would be 5 raised to 4. Then you have y raised to 4. Okay, do not be confused by 1. The 1 here is the exponent of the variable y and the variable x. That's why you have 1. Okay, so simplifying, we have 4 to the 4th times x to the 4th over 5 to the fourth and y to the fourth. So 4 to the fourth is 256 x to the fourth over 5 to the fourth is 625 y to the fourth. Okay, this of course law would mean would involve or involves the division operation. Now, how about if we have similar, what is this? Ah, no, this should be x. This is not y, that should be x. X raised to m over x raised to n is equal to x raised to m minus n. Okay, they should have the same base. The base of the numerator and the denominator should be the same so you can perform this law. Okay, so for example, we have x to the seventh over x squared. Okay, so what we're going to do, since you know that they do have the same bases, so this will be x, that's the base, and then you get the difference of the exponents of the numerator and the denominator. So we have x raised to 7 minus 2. This will give you x to the fifth. Okay, so we also have here x raised to 3s plus 1 over x raised to s plus 1. Okay, check the base. They are similar. They have the same bases. So we can use or apply the fifth law of exponent. So just like what we did in the first example, we copy the base x. Then the first exponent, the exponent of the numerator is 3x plus 1 minus the exponent of the denominator, the quantity s plus 1. Okay, please don't forget the parentheses. Simplifying, we have 3 x raised to 3s plus 1. Negative times s is minus s. Negative times positive 1 will give you minus 1. So if we simplify this, 3s minus s will give you 2s. 1 minus 1 is 0. So the final answer is x raised to 2s. Now, it says here, note that 1, this is a different um, law. So for example, if we have negative 1 raised to n, okay, negative 1 raised to n is positive 1 if n is even. So for example, if your exponent is even, okay, let's say 2, negative 1 times negative 1 is always a positive 1. Okay. Now, if it's odd, then it will be negative 1. Okay? Kasi pag odd siya, let's say 3, negative 1 times negative 1 times negative 1 will give you negative 1. So kung 5 naman exponent, negative 1 times negative 1 times negative 1 times negative 1 times negative 1 is negative 1. So if the exponent is odd, then the answer for negative 1 raised to n is always a negative 1. If n is even, then negative 1 raised to n will always be positive 1. For all n exponent, an element of the natural numbers. Okay? When we talk about natural numbers, these are your counting numbers, which are integers that usually starts from 1. 1, 2, 3, 4, 5, 6, 7, and 8. Why do we have this restriction? If we do not have this restriction, n can take a form of a fraction. It could take the form, it could become 0. And if it's 0, then this one does not hold anymore because any number raised to 0 is 1. Okay, so this will not hold because 0 is neither odd or even. So hindi na natin lalagyan ng ganyan just in case. So we have the restriction that n is an element of the natural number or counting number n. Okay. All right. Are you guys still there? Yeah, I think you guys are still there. You're just too shy to probably answer my question. So yeah, I just assume that you are still there. and eager to listen to what I have to say. Can you guys give me a smiley emoji so I would know that you are still there? Okay. Si Rhea Lynn, nandyan ba siya? Baka yung iba nanonood ng ng ML playoff season. Konti na lang. That's the only one is responding. Christine also is still there. Okay, let's proceed with multiplication. Okay, multiplication of algebraic expressions. Okay, so we have some rules here. For multiplication of monomials, multiply the coefficient by following the rule for multiplication of signed numbers to get the coefficient of the products. Then multiply the literal coefficients by following the laws of exponent to obtain the literal coefficient of the product. So this is pretty basic, I know. So for example here, quantity 5x cubed y squared times 3xy cubed. So you just multiply 5 and 3. So you have here, and then you have x cubed and x. So x cubed, 3 plus 1, okay, following the laws which we just discussed earlier. Then you have y squared and y cubed. So that would be y squared plus 3. Okay, which will give you 15, x to the fourth, y to the fifth. So for multiplication of polynomial by a binomial, apply the distributive property of multiplication over addition or subtraction. Okay, so ganito lang siya. So here, 4 times x squared, this is a monomial, multiplied by a polynomial, quantity 2x minus 3x squared minus 8. So you just do the distributive property of multiplication over addition. So 4x squared times 2x will give us 8x cubed. 4x squared minus 3x squared will give us minus 12x to the fourth. Then 4x squared times negative 8 will give us minus 32x squared. So that's simple. Now, for multiplication of polynomial by another polynomial, take one term of the multiplier at a time and multiply them and multiply the multiplicand. Okay, combine similar terms to get the required products. So this is pretty much long, the process. So you have here for a binomial multiplied by a binomial, you can distribute the first term first, and then the second term to be distributed to the next one, and then you just group similar terms and you get the final answer. Or you can also use the FOIL method. Okay, I'm going to give that as your assignment. I know that you know that already, but just in case you forgot it, I'd like you to go to YouTube later and search for the FOIL method in multiplying binomials. Okay, so I'm gonna leave that to you. And same was true with the lattice multiplication, because that's kind of hard to teach it here without my whiteboard yet. So I'm going to leave that also as your assignment, just in case you don't understand what was written in this module. Okay, so you can check out how to perform the lattice multiplication using there's a lot of resources on YouTube, and they make things simpler, okay, if you're going to watch them. Okay, that will be your assignment. Now we proceed with the division of the algebraic expressions. I am a bit in a hurry because we only have 10 minutes left before I have to end this live, because we cannot go beyond an hour. So we have the division of algebraic expressions. Okay, we have some rules here for division of a multinomial by a monomial. Divide the coefficient by following the rule of division of signed numbers to get the coefficient of the quotient. Divide the literal coefficient by following the rules of exponent to obtain the literal coefficient of the quotient. In other words, to divide a multinomial by a monomial, we divide each term of the multinomial by the monomial by following the rules of exponents. So this is what it means. For example, we're going to divide 27 a to the fourth b squared over 3a cubed b. So what you're going to do is you just group them, okay? So just divide the literal coefficients. So here, 27 and 3, 27 divided by 3 will give you 9. This should be 9. Yeah. Then you have a to the fourth divided by a cubed, okay? So based from the laws of exponent, we just subtract the exponents. So a to the fourth minus 3. So that will give you a. So for b squared and b here, b squared minus 1 will give you b. So the answer here is 9ab. So for polynomial by a binomial, if you're going to divide that, so we can have this polynomial here, quantity 6m cubed n squared plus 3m squared n over 3m squared n. So if it's a polynomial divided by a monomial, you can actually separate them, okay? So just like this one, 6m cubed n squared divided by 3m squared n, okay? So this is divided by the first term. And don't forget the operation between them. It's positive. So we have plus 3m squared over 3m squared n over, again, our denominator, 3m squared n. And then you can use the laws of exponents. So 6 over 3 will give you 2. M cubed over m squared is m raised to 3 minus 2 will give you m. Now n squared over n will give you n. Okay? Now we proceed here. So we have 3m squared n over 3m squared n. So if you see, guys, they have, like, these two are equal, no? 3m squared over 3m squared n and 3m squared n are equal. So if you are dividing, this is like dividing a number by itself. So we know that when we are dividing a number by itself, it's always equal to 1 except for 0. So we have 1 here. So this whole term divided by itself will give us 1. So the answer should be 2mn plus 1. Okay, so that's what you can do. Now, the same is true here in number 2 example. So we have 1, 2, 3 terms divided by a monomial. So you can divide all these terms with this monomial, taking into consideration the signs. So here, positive divided by negative. So this should become negative. And this second term is negative divided by negative. So later, this will become positive. Okay. Then we have negative divided by negative. This will become plus also. Okay. As shown here. Okay. So we have minus and negative. It will become positive. Minus and negative. It will become positive. Positive and minus will become negative. So the answer here is minus 3z squared plus 4xyz plus 3x squared y squared. Okay, so you may ask, what happened to y and z in the first term? So if you notice here, x squared over x squared, dividing this term by itself will be 1. Then y over y will also be 1. That's why you don't see x and y in the first term anymore. because they became 1. Okay? X squared over x squared is 1, y over y is also 1. What's left here is z squared over z. So this is z cube pala. So z cube minus 1 will give us z squared. That's the same process with the second and the third term. Okay? Now, to divide a multinomial by a multinomial of lower degree, we use long division or the synthetic division. I'm sure you are very much familiar with the long division and the synthetic division. Okay, so this is how it's done. It's really hard to encode this one kasi ganito yung ginawa niya. Dapat gumamit siya ng formula. The module we're using actually, guys, is a collaboration with other professors in other ISU system. So it's not only me who made this. I actually made chapter 3, if my memory serves me right. 3 or 7. I'm not really sure. Okay, so yeah. So this is how you do long division. I'm going to leave that also to you. I'm sure you still remember how to perform long division. Okay, or you can have also uh what do you call that? The synthetic division. Okay. So yeah, I think that would be also. If you guys have questions, please let me know. Or if you want some additional explanations, please let me know in our group chat. Okay. Sige. I'll just teach you this one. Baka sabi, di naman niya tinuro. Okay. In-assume naman niya na alam namin. Okay. But of course, I really have to assume that you should know this because these are basic topics. These topics are part of your course, I think, in senior and junior high. So i-try lang natin. So we are dividing here 9x cubed minus 3x squared minus 3x minus 4 by a binomial 3x plus 2. So when we are working on this, first you have to consider the first term. Okay? You have 9x squared. So the idea here is we need to get a 9x squared so that when we subtract it, this will become 0. Okay, so we have here our divisor, which is 3x plus 2. So the question now is what should be multiplied to 3x to get 9x cubed? Okay, and the answer is 3x squared. So this is the first term. So 3x squared times 3x will give you 9x cubed. Okay, then you distribute this because we are multiplying this with the whole of this. So 3x squared times positive 2 will give us positive 6x squared. Then we subtract. 9x cubed minus 9x cubed, so 0. So that's our goal, ano? Maging 0 siya if we subtract. So na-achieve natin yung goal natin. 3x squared minus 6x squared will give us minus 9x squared. Again, since 9x squared yung highest exponent, our next goal is when we subtract the product of 3x and the number with minus 9x squared, the difference should be 0. So ano ang i-multiply natin sa 3x squared para makakuha tayo ng negative 9? 9x squared. Negative. We need a negative 9x squared. So since 3x ito, so what should we multiply here? We must multiply minus 3x. So let's see. Minus 3x now, or negative 3x times 3x will give us negative 9x squared. So na-achieve natin yung gusto nating mangyari. Diba? So next, we have negative 3x times positive 2 will give us minus 6x. Then we subtract negative 9x squared minus negative 9x squared is 0. Negative 3x minus negative 6x will give us positive 3x. Kasi negative times negative is positive. So 3 minus 3x plus positive 6x will give us positive 3x. Then we bring down the last term, minus 4x here. Bakit hindi niya nakuha na minus ito? Bring down negative 3. Parang short. This should be minus 3x. Sorry. So bring down minus 3x here. I think, ayun. Ito pala. So tama. So 3x, bring down minus 4. Minus 4 yan. It's not positive 4. Kasi negative 4 yan. Okay, so what is left here is 3x. So what should be multiplied with 3x to get a positive 3x? So we just multiply 1. 1 times 3x will give us positive 3x. Then we have 1 times 2 will give us positive 2. And we subtract this. 3x minus 3x will be 0. Negative 4 minus 2 will give us 6. Okay, so this should be minus 6. Our remainder here is negative 6. Okay. Questions? Okay. Your questions will be entertained in our group chat room. Okay, so if you have questions there, just go there and ask me anything about what I have discussed for today. So I guess I'm going to end now my live lecture discussion. Okay, even though you guys are only around 7, I think. Yeah, that's still a good number of students watching right now. So please let your classmates watch this video. So since there are no more questions, I'm going to end this. Hope you guys have a great night. Enjoy your dinner. God bless and see you again next time. Bye.